Okay, so next thing we're going to talk about is the types of zero. This is also very important. This is also very important. That means that when you guys read the questions, you have to read the question really, really carefully. What kind of zeros they want. Okay, so if they want you to list all the possible rational zero, that means you have to use the P over Q, like the one that we just did here. So this is what they want. Again, this is called possible zero. That means that it's not the real zero, it's maybe a zero. So that's why, so if you want them to list a possible, this is what you do. Second, if they want you to give me the rational zeros, so what happens when I want a rational zero? Rational zero means you can only give your answer in form of P over Q, in fraction. That means that you cannot have a square root as a zero. You cannot have I as a zero. You cannot have pi as a zero. So when I ask you for rational zeros, these are the numbers that we call rational numbers, which is numbers that can put into fractions. And that are the zeros that we are looking for. So let's say that when you find this, let's say you look at this graph, and this graph have -2. Let's say this is square root of 5. And let's say this is square root of 7, for example, just an example here. So what happens in this case that if I want you to list the rational zero, your answer is only -2. You cannot list these two zeros because they are not rational. You guys clear what I'm saying here? And if they want you to find the real zeros, real zero is all zeros you can have, but cannot be imaginary. So if a question wants you to list all the real zeros for this graph, then your answer will be -2, square root of 5, and square root of 7. So you cannot have any imaginary. And what happens if they want you to list all zeros? All zeros means it can be real and it can be imaginary. So you have to read, when you do my test, you have to be careful because you have the questions that I ask you depends on what kind of zeros I want you to have. The list of possible rational zeros, this is the answer. Rational zeros, then if you find your zero, then you can only take in the form of fraction, like -2, 0, 1/2. If I want you to give me the real zeros, it can be any zeros, but it cannot be imaginary. And if a question listed all zeros, all zero means every zeros, including real, including imaginary, everything else. Okay, so be careful with this. You guys all right here? Questions you have with this before we go on with your homework question? Okay, so like these are very easy, like question 7. Determine the number of zeros that you can have in this function. Karishma, Justin, you want to guess how many zeros you can have? This is based on the first theorem that I show you, the zero theorem. That means the one with the highest degree, then that will be that number of zeros you have. So can you tell me how many zeros can you have in numbers question 7?
5.
5, because the highest degree here is 5. Your power is highest 5 is 5. And this one, number 8.
6.
These are very simple. Okay, this is using the rational. So make sure you guys know that this very important. When you say 6 means you have to give me all 6 zeros in this case. So if you have 5, that means you have all 5 zeros. Number 9. Now, so use a rational zero test to list the possible rational zero. So this is a question that asking us to list the possible rational zero. This graph is redundant. You do not need to look at the graph. So what happens if a question wants you to list the possible rational zero? What do you need to do? You have to use what? The rational zero theorem. Yes. So if a question wants you to list the possible rational zero, you have to use the rational zero theorem that we just did here. So I want both of you guys to do question 9. Remember last time how we do this is I give you the polynomial. I say, give me all the factors of 9 and give me all the factors of 1, the constant and the leading coefficient. So this is your time to tell me what is your factor in this case. So by looking at this, can you tell me what is your 81, right? So can someone tell me what is a factor for 81? Justin and what times what is 81? Karishma, Justin, what times what is 81? The reason why it's 81 is this one. We don't care about the one in the middle, only the leading and the constant. Justin, Karishma?
9 times 9.
9 times 9, so you just need 9.
Yeah.
What else? 1 and 81 for sure, right?
Yeah.
That is for sure. You should know that 1 times 81. So what else? You have more.
Wouldn't 3?
Yes, 3, because 9 is a factor of 3. So 3 times what is 81? 3 times
27.
Yes. Any else? Anything else? That's it.
Yeah.
So how do I know that's it? You know, was how do we know? So what do I do here is I take out a calculator and then I divide. So 81, you know, it's not divisible by 2 evenly, right? So 81, 2 is out. 3 is good. 27, you told me. You do 4, 4 is not good. You do 5, 5 is not good. You do 6, no good. 7, no good. 8 is no good. So the reason why I say all this no good is because you see decimals at the back, but 9 is a 1. And you find out that not why we stop at 9, why we don't go 10, 11, 12 is because 9 is the middle. The square of 81 is 9, so that right in the middle. So once you take a square of 81, which is 9, you stop at 9. So you do 1 till 9. And this is all the factor for 81. You guys got it?
Yeah.
And then the leading coefficient here is 1. The good news is, what is the factor for 1?
1.
Just 1. So what is the leading coefficient? The rational zero test telling us is you take all this is P and all this is Q. And again, class, do not switch this around. If you put Q and P, it's all going to be fraction and it's going to be wrong. So can you tell me give me the list of all these zeros you can have? So you take all this P divided by the 1. So what you get? You get exactly the top, but with plus and
negatives.
Minus. So the first one you have 1 comma with negative 1. So you had to do that. 3 comma with negative 3. 9 comma with negative 9. 27 comma with negative 27. Make sure you put a comma next to it, because I got students forget to put a comma to separate them. They can mark it wrong. So this is how you do it. And this is where they want you to list the rational zeros. You guys doing okay here?
Yeah.
Okay. This one, if possible, the rational find the rational zeros of this function. So between this question that you just did 9 and 10 and 11, when they want you to find the rational zeros, is that the same thing as listing? Is these two questions the same thing? Oh, I take 30 and I do the same thing I did just now, 31 and 30 and so on, and then I do the plus minus. Is that going to be the same thing for question 10, 11, 12, and so on? Yes or no? Karishma, Justin?
Yes.
No, this is not a part of it. So this question on top is asking to list, which is this one. This is question 10. But when you look at question 11, 12, 13, 14, they want you to list the rational zero. This is the one they want you to do. Question 11, 10, not 10. This is question 9, sorry. Question 10 to question number 13, they want you to give me the rational zero. So it's not just list 1, -1, 3, like this. You actually have to find them. You guys with me here? So let's do this question. Are you clear with this one? I just want to point out to you guys, because this is something that a lot of students did wrong in my test, is because they did not read the question carefully. And what happens when they did not read the question carefully is they got this. They got a lot of wrongs. So for this question, number 10, you still need to give me your PQs. So 30, right? Can someone, can one of you guys tell me what is the factor for 30, one pair? Karishma, Justin, a pair of 30s? Karishma?
The
Number 10.
So 1 would go inside, and 3.
Can 2 goes to 30?
Yeah, 2.
Okay.
And 3.
Uh-huh.
And
So 1 goes into 30 times, right? Right?
yeah,
2 goes into 30 how many times?
15 times.
15 times. 3 goes into 30
10 times.
10 times. What else?
And 6.
6 goes into 30 how many times?
5 times.
5 times. So these are all the possibles, the factors for 30s. The good news about Q is the factor for Q is just 1, right?
Yeah.
Because the leading coefficient here is 1. So you got 1. So then you take all this over 1. So it's plus. So your answer in this case is plus minus 1, 2, 3, 5, 6, 10, 15, and 30. And if you give me this answer over here, you will get wrong, because this question did not call you to list the possible rational zeros. This question is asking you for the rational zeros. So once you get into here, you have to do syntactic division. One of these numbers. So the coefficient, let's try 1 first. So it's like as I told you, it's a jigsaw puzzle game. You have to try a Sudoku. And you have to try to when this fellow becomes 0. If that does not become 0, you have to try with another one. So what are the coefficients you have to put in here for your syntactic division?
1
Mm-hmm.
and 0,
Very good. If you forget your zero, say goodbye to the whole thing.
-31 and -30.
Perfect. So I'm gonna try 1 first. So I drop the 1. 1 times 1 is 1. Make sure you add this, become 1. 1 times 1 is 1. -31 times 1 is plus 1 is -30. 1 times -30 is -30. So unfortunately, this doesn't give me 0. But you know, this one is a little bit off, right? So if this is plus, it's perfect. So what do I do? Karishma, Justin, what do you think about? This one doesn't give me 0. So what do I change it to?
-1.
Very good. You change to -1. So hopefully that this will become 0. So drop the 1. -1 times 1 is -1. 0 times -1 is -1. 0 plus -1 is -1. -1 times -1 is 1. Add this, you get -30, and -1 times -30 is +30, and this gives me 0. So now we know that -1 is a 0. That's your answer. But as you know that this is a power 3, right? So when you have power 3, how many answers you should have? How many zeros you should have?
3.
3. So now we found 1, your -1. So my question is, how do you find the other 2? Do you want to, okay, now let's try 2 and -2, 3, -3, 5, 6, so on. Do you want to do that? This is what people do in my test, and they spend a whole hour doing this. And guess what? You will spend a whole hour doing this, which is you're wasting all your time. So there is a way for us to do it. This is what you learn in 3.3. You take your quotient and you can find your other 2 zeros using this. So what is your quotient got here in terms of x and x squared?
It's x squared minus x minus 30.
And this is equal to 0. So now we can find the other 2 zeros using this quadratic, either by factoring or quadratic formula. So I would recommend factoring because it's a quicker way to do it. X squared is x and x. What times what is 30? We got this already. Which one is give us 30? And when you add and subtract, you get -1. What's the number we should put in here? What's the factor for him? 30. Karishma, Justin?
Wouldn't 1 be -30?
No, I need a 1. So 30 and 1 doesn't work yet.
Okay.
Which one of these pair give us difference of 1?
So -6 and then x plus 5.
Perfect. So this is a factor for him because -6 plus 5 is a -1. When you multiply, you get -30. So then you can make this equal to 0. So -6, if you make it equal to 0, it becomes 6. And this will give me -5. So what are your other 2 zeros? My other 2 zeros will be 6 and -5. So this is your answer for question 10. You guys with me here?
Yes.
Okay. And again, they want us a rational zeros. So these are all rational because it belongs to here, here, and here. So see the 1 and 5 and 6 is here. So they are rational. So this is your answer. what happens when you do this and you get x is square root of 6 and x is -5? Let's say you got these two answers plus a -1. So which one you need to report as your answer if you get this kind of answer? Can you report square root of 6 in here?
No.
No, yes, you only report these two answers, -1 and -5. So make sure you guys know, because of the word rational, you can only report rational zeros, not square root, not imaginary. You guys with me here?
Yeah.
So this is for question 10, question 11, question 12, and question 13. So this is for 10 till 13, where they want you to find the rational zeros. Okay. -1, what else? 5 and 6, 6 and -5. Questions with this?
No.
Justin, you okay there? Justin, are you there? Probably not there. All right, so so this is how we find. So make sure you guys. So that's why I want you to know the difference. And what happens to question number 14? What's the difference between 13 and 14? What's the difference between 13 and 14? 13 is for what kind of zeros? Rational zeros. And 14 is for what? Real zeros. Again, solutions and zeros are the same thing. And what is the difference between these two answers is, now last time when you have square root of 6, you say you cannot have it. When you have a real, square root of 6 is a part of your answers. Okay. So how do we do question number 14? Oh, by the way, do you guys need to take pictures of this? Number 10. So this is for question 10 to question 13. Maybe I take a, maybe I do. So this is for rational zeros. And then for question 14, this is for real solution. Real solution is the same thing as real zeros. So we do not, I mean, it's the same thing. So make sure you guys know the difference. And when you guys do my test, please read the question really, really carefully, because a lot of students, you know, they didn't read the question carefully. So what do we do with this? It's the same thing. You do your P and you do your Q. If they don't give us any zeros, you have to give me your PQs. So Karishma, what is your P in this case? The factor of what for question 14? Your P is Karishma? Karishma, P is what number?
P is -6.
You can ignore the negative, just say 6.
Okay.
Because of the plus minus, it will take care of your plus, your negative or your positive.
Okay.
So can you give me all the factor for 6?
Okay. It's going to be 1, 2, 3, and 6.
Perfect. And Q
Is 7.
is 7. Very nice. And the factor for 7 is
1 and 7.
okay. Now what you need to do here is you have to take all this over 1 and take all this over 7. So when you take all this over 1, you still get 1, 2, 3, and 6. And now you take all this over 7, you got 1/7, 2/7, 3/7, and 6/7. Don't forget you got plus minus here. That means every single one of these has 2 choices. So this is your PQ. This is not your answer. This is just a possible. So what you do now is you have to do a synthetic division. We got 7 here. We got 8. We got -15. And we got -6. So this is the one that, and when you perform one of this, your remainder has to be 0. So Karishma, which number you think you want to try here first?
1.
Okay, let's try 1. So drop the 7. 1 times 7 is 7. Add this on, become 15. 1 times 15 is 15. Becomes 0. 1 times 0 is 0. Does that give us 0 here as your remainder? No. So 1 does not work. So what do you want to try? This is where a lot of students will have struggled with in my test because they have to do this. Pick one of these numbers. We'll try 2.
2.
Yeah, and don't spend 30 minutes. Then you lost all your 30 minutes. Just keep on going. So drop the 7. So 2 times 7 is what? 14. Add this one up. Become 22, right? 2 times 22 is
44.
44. What is that going to be? 44 minus 15, 29. And you do not need to figure out the last one because we know it's not going to be what?
It's not going to be 6.
It's not going to be 6 here, so it's not going to work. So 2 does not work. So do you see the dilemma of students here now?
Yeah.
I'm going to try -1 because we try 1 does not work. -1 might work. You know what I'm saying?
Oh, yeah.
So don't forget, it's a plus minus. So -1 times 7 is -7. That give me 1. -1 times 1 is -1. This is -16. This becomes 16. So this one also does not work. So now I can cross out 1 here because plus minus 1 does not work. Let me see what will work. I might try -2 since we got 2. So that's the reason why that I told you last week, Karishma, that you had to do your synthetic really good because this is what you have to do. This is -14. This will give me -6. That looks promising. Can you finish this one up, Karishma?
So -2 times -6 will be 12. So then that would be -3. And -2 times -3 is 6. So it equals 0 with the remainder.
So this is that sounds good, right?
Yeah.
So now you know that one of the zeros will be what? -2. And what do we did last time? Once you find your zeros, you take the quotient and you factor it, right?
Yeah.
Same thing here. You take your quotient, which is 7x squared minus 6x minus 3 equals to 0. I won't want to factor this one because of the 7 in front. See, last time you have a 1 in front. Yes, I recommend you to factor it. But this one, you got a 7 in front here. So I would recommend you to use the quadratic formula. You know your quadratic formula, Karishma?
Sorry. 1 minute. Okay, so
it's negative b plus minus square root of b squared minus 4ac all over by what?
2 times a.
2a. So negative b is this one, right?
Yeah.
The double negative will become 6. And then you b squared means you square your negative 6. What is the square of negative 6?
Wait, so why aren't we not factoring it out? If it can't like divide out, then we do the quadratic.
Yes, as I told you, the reason why is because of the 7 in front here.
Mhm.
And not all quadratic can be factored. Remember, sometimes a quadratic can be a prime. That means you cannot factor it.
Okay.
And if a quadratic is a prime, means you cannot factor, then you have to use your quadratic formula.
Okay.
And the reason why we can factor this one is because of the 1 in front. Usually when you get a 1 in front, I will recommend you to factor it. But once you get a number in front, like a 2 or 3 or this time 7, then I will recommend you to use the quadratic formula here.
Okay.
Yep. So, and again, not all quadratic equations can be factored. So square of negative 6 is 36. Minus 4 times a is 7. And c is a negative 3. All over by 2a. 2a is 2 times 7. This is 14. So now what do I do here is I take all this inside the square root. I take out a calculator and do that. So 36 minus 4 times 7 times negative 3. So this is all going to be 120. So this is 6 plus minus square of 120 over 14. And so that's why we know this one cannot be factored, because 120 is not a perfect square. If this number is a perfect square, like 9 and 4 and 36, that means you can factor this quadratic. Since this is not so 120 is not a perfect square, so you have to break this one down. Do you know how to break 120 down? Square of 120? Remember last time when you do square root of 12, in order for us to break it down, you take a perfect square factor, 4 times 3. And 4 is a perfect square of 2, so this becomes 2 root 3. So you're going to do the same thing for this, but this time is 120. So 120 is 4 times 30. 30, I don't think so. These are the factor for 30. None of them are perfect square. So this is 2 root 30. Because 30, if you remember, this is the factor for 30 that you give it to me, remember? None of these factors are perfect square, except for 1. So that's why you cannot break 30 down. So your answer in this case will become 6 plus minus 2 root 30. And then when you over by 14, now you can reduce this. And how do you reduce this? Not like this. If you do like this, oh, 2 goes into 14 7 times, this whole thing is wrong. So how do we reduce this is you have to divide this 14 twice. 1 over here and 1 over here. So that now you can reduce this 2 and 14 to become 7. 6 and 14 become 3 over 7 because they divide by 2. So this quadratic formula will give me 3 plus minus square root of 30 over 7. And this is considered real solution because of a square root. So your answer in this case will be -2 3 plus square root of 30 over 7 and 3 minus square root of 30 over 7. Your online homework does not like plus and minus symbol. So do not put plus minus here. They will mark it wrong. You have to separate your answer twice, one for plus, one for minus. But for my test, yes, you can just do like this and -2. This is your answer in this case. Yeah, I'm not picky like your online homework. So if you give me plus minus, I'll take it. So your answer in this case will be these 3 answers. One of them is rational. The other 2 is what we call as irrational. But all those are considered real because you cannot have I4. So this is the answer for question number 14. Questions?
No.
Okay, so make sure you read the question really carefully, what's going on. Same thing happens to 15 and 16. What is 15 telling us to do is first you have to what? List all the possible rational zeros. So you have to use your PQs, this one. This is what we call as to list all your possible rational zeros. And once you list them, you don't graph first. You determine your zeros. How do you determine your real zeros? It's just what I just did just now here, number 14. And once you did it, then you begin to graph. So graph came on very late. So how do we graph this kind of, so you do A first, and then you do C next, which is the real zeros, and then you do B, graphing. So how do you graph this kind of, this equation? Is once you got your zeros, you can graph this. And how do you graph this is change it back to decimals. So the first one we have is 3 plus root 30. So I'm going to do root 30 first, plus 3, and then divided by 7. So this is 1 point something. This is 1.2 something. Okay, using my calculator, this is 1.2. And then the other one is minus, so root 30 negative plus 3 divided by 7. So this is negative 0.353. Negative 0.353. So how do I graph this graph? So we got a -2. -2 is right here. We got negative 0.3 somewhere like here, and we got a positive 1.2. Okay, so these are the 3 zeros that we have. And if you look at your equation, the equation that we have here is a positive 7x cubed. A positive 7x cubed means that you rise on the right and you fall on the left. So now we can graph this. That means this one will go all the way up and cross here, and then it will turn around and cross at negative 0.03, which is, and then you curve back up and then go up there. So this is your graph for part C. So when you draw, once you figure out your zeros, and you will able to do your graph very easily. So when you guys do question 15, 16, these 2 questions, what you need to do first is find the possible zero, A, and then do C first, which is finding the zeros, which is all this work. And then once you figure out a zero, then you graph. Your graph will look very similar to what we have right here. So that's the reason why that I would recommend you to, and then you'll make sure your zeros is the one that you're looking for here, your x-intercept. So this is how we graph, draw a graph. So I would recommend you to do A, and then C, and then back to the graph, which is B, for question 15 and 16. You guys all right? Questions with me?
No.
Okay. You need a picture for this? before we go on a little bit more? Because we will continue this tomorrow in the Zoom. Because 3.4 is a big section. You guys go ahead and take pictures. If you are done taking pictures, because I will get a new one. You guys okay?
Yes.
Okay. Justin, are you there? It's quiet. Justin? All right. Next is to write a polynomial functions given as 0. So 17 and 18. Now, if I give you zeros and I want you to write a polynomial function, the first thing you need to do is you have to figure out how many zeros do we have here. And then once you figure out zeros, you have to write this in a factor form. Factor form means is x plus k. And then after that, you have to FOIL this out. And then you will get your polynomial answer. Then you get your answer. So for question number 17, so pay attention, this is very important. How many zeros they give us to us? Question 17, they only give us 2 zeros, but how many zeros do we have actually? Karishma, Justin?
What did you ask? Sorry.
We have the question 17 gives us 2 zeros, right?
Okay.
2 and negative 3i. So how many zeros do actually these polynomial functions have? 3.
3.
So can you tell me where is the other zeros? I only give you 2 here. Where's the third one? Don't you remember the complex zeros? And what is the complex zeros? The conjugate zero, sorry, the conjugate zero. What does the conjugate zero says? If negative 3i is a 0, then what happens?
It has to turn positive.
So positive 3i is also what? A 0.
A 0.
So in this case, this is what happens in your test and your homework. If you see an I form like here, like 8, 17, and 18, like 18, they only give you 3 zeros, right?
Mm-hmm.
But how many zeros actually does question 18 has?
5.
It has 4 zeros.
4.
Which is what? Can you give me the zeros for question 18? Negative 1, 7, 3 minus 2i, and what else? These are the 3. What's the fourth one?
Positive 2i?
No, don't forget, this is all together.
Oh. 3
So
plus 2i.
Yes, you are correct. Now, next thing we need to do here is we know the zeros. This is all the zeros. Next thing we need to do is we have to write this in a factor form. So how do we write 2 as a factor form? Is you put x minus 2. And how do you write negative 3i as a factor form? Is x plus 3i. And how do we write 3i as a factor form? Is x minus 3i. So what happens when you write this in a factor form? You have to take all your sign and interchange it. Means if you have a plus 2, it becomes negative 2. If you have a negative 3i, it becomes plus 3i. And if you have a positive 3i, it becomes negative 3i. And don't forget, each one of these must have an x in front of it. So I got student just tell me negative 2, 3i, and 3i. This is not the factor form. The factor form has to be do like this. Has an x in front. So this is the factor form. And how do you figure out your polynomial? Is you have to FOIL it. Now, a lot of students FOID this 2 first. I want to tell you, if you FOID this 2, it's going to be very icky. The reason why is because you got real and you got complex, imaginary. So when you FOID this, you got everything. So what I suggest is do not FOID the first 2. FOID the last 2. FOID the imaginary one first. Because FOIDing the imaginary one is easier than FOIDing those. And when you do this, you will get a very nice answer. Okay. So if you FOID this, you will get x squared. And when you multiply the x to the negative 3i, you got negative 3xi. And when you FOID this to the other one, you got a positive 3xi. And then when you do the last one, you get negative 9i squared. And what do you notice about this is these 2 will cancel out, become 0, because 1 is plus and 1 is minus. And what is I squared is? You guys remember? Karishma? Justin? You learned this in previous class. I squared is what?
I don't know.
Negative 1. I squared is negative 1. So you have to change this, become x squared. Negative 9 times negative 1. This is a positive 9. And then you drop this x minus 2. And you FOID one more time. And then that will be your answer in this case. So this is how we do 17 and 18. So my question, I think you guys know how to FOID this one out. And don't forget, because it's a function notation, so a lot of students in the test, they forget to put f of x. So make sure you put f of x. That's why this question really given us f of x in here. So you do not need to put f of x in here. But in your test, make sure you put an f of x inside here. So now my question is, how do you write all this in a factor form? Karishma, how do you write this in a factor form? For number 18.
Wouldn't it be x plus 1, x minus 7,
now the I form.
3.
Don't forget x. You have the x first.
X.
Switch all your sign.
X plus.
No, this is plus already.
Okay, x plus 3.
Switch all your sign.
Oh, x minus 3 plus 2i.
This one, the fourth one.
It's going to be x minus 3 minus 2i.
Perfect. And do you know what happens if this is wrong? All your foiling, when you do underneath it, is all going to be wrong. So that's the reason why you have to know, switch all your sign, everything. And don't forget to put an X. Now, how do you FOID this? In order for us to FOID this, first we FOID this 2 first because it's a nice number. And we also FOID this 2 because it's imaginary FI form. So this one is easy to FOID because it's a nice whole number. So when you FOID this, you will get x squared minus 6x minus 7. This is easy to FOID. But however, foiling this, the last 2 here, is going to be a bit nightmare. The reason why is because this is a 3 terms and this is a 3 terms. That's 1, 2, 3, and 1, 2, 3. So when you FOID this, you end up with a 9 terms. So I'll show you how you FOID this one. So x times, so you take the first one and multiply everything in the back. So x times x is x squared. And then x times negative 3 is negative 3x. Then x times negative 2i is 2xi or 2ix. So this is using x. And then I'll take negative 3 and distribute to that. So negative 3 times x, I get negative 3x. Negative 3 times negative 3, I get a positive 9. The reason why I put in here is because I put them all in the same term. And then negative 3 times 2i, I will get positive 6i. And then I'll take the 2i multiplied by x, I will get positive 2xi. And then 2i times 3, I will get negative 6i. And then 2i times negative 2i, I will get negative 4i squared. And as usual, the I squared, I make it as negative 1. So negative 4 times negative 1 is a positive 4. So what happens when you combine like terms here, you find out that the 2xi will cancel. You can also find out the 6i will be canceled. So this is what happens when you FOIL a conjugate. Okay. So when you FOIL a conjugate, all your I terms is canceled. This is special. If you FOIL a conjugate and your I term does not cancel, means something is wrong here. Okay. So those students, for you guys, if you try to FOIL a conjugate factor here, your I term will be all canceled. No more I here. So what I have here is x squared minus 6x plus 13. And don't forget, I still have the early one that you FOIL. X squared minus 6x minus 7. And now you have to FOIL it one more time. So you take the x squared and distribute to all this. And then you take the negative 6x and distribute to all those, and then you take the negative 7 and distribute all those and combine like terms, and that will be your answer. And this is how, and then forget to put your f of x in front. So this is how you do question number 18. So that's a lot. So if a question wants you to write a polynomial functions, that is a lot of foiling involved in this kind of question. And again, a big hint, if you FOIL the conjugate, all your I term will be canceled out, like what you see here. And if you don't cancel your I term, something is wrong in this case. So that is how we do question 17 and 18 to write this in the, the polynomial function form. You guys okay here?
Yeah.
We're gonna stop here. The reason why is because we are running out of time, but so the rest of it we will talk about it in tomorrow. So we stop at 18. So go and try to do 1 till 18, and then later on from 19 onwards, we'll talk about that in tomorrow's class. So there are more theorems. So what we did here, the 3 important theorems that we talked about just now, is from 1 till 18. So when we start 19 tomorrow Zoom meeting, I will introduce you more theorems. Yeah, there'll be more theorems coming up. Karishma, you okay?
Yeah.
This is tough. I didn't say this is easy. This is even tougher than 3.3. All right, so I'm gonna stop sharing here and I'm gonna stop recording here. You got any questions for me?
No, that should be all.